QSR, what we are doing now, we are looking for the molecular structure. One molecular structure, it has the intrinsic properties, it has the chemical properties, it has the biological properties. All right. All these properties are considered while working on the QSR. Okay. In the pharmacophore, we call them the pharmacophore features, and the QSR, we work on the molecular descriptors. Descriptors are what? Which are describing your structure, the chemical structure. Okay. The chemical structure, see, if we have to identify the relationship, if we have to make a model, okay, so while making the model, we have to make sure that whatever the input we are using, that should define your structure exactly equally. Okay. Let's take an example. Here, these are the compounds basically, and these are the compounds which are the inhalational anesthetics. Okay. And here we have concluded that more hydrophobic compounds, they are more efficient as anesthetic. Okay. That is the conclusion here. But now the question is that possible that all the hydrophobic compounds will be the anesthetic? Is that possible? That is our next question. And if not, then what other properties we will be considering? Okay. These are the features we will be considering. The pharmacophore features, the hydrogen acceptor, donor, its charge, and the presence of the aromatic ring. That thing we will be considering other than the hydrophobic property. Okay. All these things will also be considered. Now here comes the QSR, this quantitative activity relationship methods, which are important for the prediction of the effect, the biological effect of the compound based on the mathematical and the statistical relationship. Okay. While building the QSR model, basically, as I told you, the machine learning approach will be using the QSR, you can consider under that. Okay. So these molecular descriptors will be first stage. That will be the first step here. Okay. These descriptors are nothing but the numerical representation of your chemical structure. That's it. Why the numerical representation? I told you it is a mathematical thing. Okay. It is a mathematical procedure. Okay. Statistical approaches are used. So your structure where the bonds and atoms are there, that will be converted into what? Into the numerical. Okay. So your descriptors are nothing but the numerical representation of the chemical information which are encoded within the molecular structure. Okay. Now, when we talk about the types of descriptors, so in the types of descriptors, you will see it starts from the 0 dimension, 1 dimension, 2 dimension, 3 dimension, 4 dimension. Okay. 0D, 1D, 2D, 3D, 4D. Okay. And it is a 0D, like only the molecular weight and types of atoms will be there, etc. All these linear information will be there. Okay. In the 1 dimension, which functional group are there, rings are there or not, bonds are there or not, that is your 1 dimension. Okay. In the 2 dimensional, it will like the molecular connectivity indices, how they are connected. Okay. Now, when the 3D information is there in the 3D, the electronic, the steric, or the shape of the compound, all these properties will be considered. Okay. And in the 4D, they will like in the form of in the term of the conformation, that will become your 4D property, molecular descriptors. Okay. So on that basis, as I told you, 1D, 2D, 3, on these bases, the descriptors are classified. The physicochemical properties, the electronic properties, steric properties, lipophilicity, hydrogen bonding, shape, charge, all these things will be considered. Okay. And all these things are represented into a numerical map. Okay. They are designed, they are not like a structure, not a direct structure will be there. It is converted into the numerical form.